Well guys, I thought I'd just go ahead and jump right into this and give you guys an example. Now, this is not something I expect you guys to know right off the bat. We're going to be going through a bunch of tutorials. If you knew, that's great, maybe just a quick refresher for you. But I wanted to kind of outline what the remainder of the discrete math tutorials are kind of going to look like. This is something that is relatively basic, but there's a lot of steps in order to prove something like this. You can go through a truth table, which is pretty simple, but we want to do it a more interesting way. Now in this tutorial, I'm not going to really show you all the meanings of each symbol and how I'm getting to certain answers, even though I am probably going to stop by here and there, but I just want to show you what you can expect to learn by watching the Discrete Math tutorial series. So the first thing we want to do is we want to get rid of all these implication symbols. So in this proposition right here, you have a left side and you have a right side. So it's technically an implication symbol right here, and that states if this side, then that side. Within here, you also have if this side, then this side, and then within the parentheses, you also have another if then. Over here, you have if this side, then that side. And based on this implication symbol, you have if this side, then that, if this, then that. So the first thing we want to do is we want to get rid of all these implication symbols. So another way to write P implies Q is not P or Q. This is a law. If you go through a truth table, you'll see basically that everything matches. So if we just wanted to run this real quickly, true, true, false, false, true, false, true, false. If you're not understanding how I'm getting this, you're basically looking at how many different variables are located within this. There's only 2 different ones. So the formula is 2 to the n. If there's 2, there's 2 to the 2, which is 4. So there should be 4 different possibilities, 4 different rows. We also have not P over here, and we have P implies Q, and then the last one is not P or Q. So not P, the opposite of P is false, false, true, true. P implies Q, P implies Q, true implies true, that's true, true implies false, that's false. False implies true, that's true, false implies false, that is true. So not P or Q, so not P is false or Q, so false or true, which is true. False or false is false. True or true is true, because this is the disjunctive or. And then true or false, which is also true. As you can see, everything matches between these 2 columns, so they are identical. So basically what we're going to do now is start off. So since we have 2 different sides, the left side, we can consider this our P and this our Q. We can negate the left side, so not P implies Q implies R, and then this implication symbol becomes an OR symbol, and then we just rewrite everything else. P implies Q, and that implies P implies R. So now we've got to the point where I decide to work on the left side first. It looks simpler than the right side, so we're just going to work on the innards of that one. So not P or Q implies R. So what we just did is negated the P and switched that to an OR, because there's the left side, there's the right side, and then we'll continue on with not P or not Q or R, and that just does the inside modifications. So then we're going to distribute the not symbol, and you're going to be studying about De Morgan's law pretty soon. So we have P, and then when you distribute the negation symbol, the OR symbol becomes an AND symbol. We're going to distribute the negation symbol in here, so that becomes a not Q or R. So then the last thing we can do is distribute this negation symbol within here. So we get P and Q and not R. So we can bring down the remainder, because this is about as good as it gets right here. We have 3 different variables. There's really nothing else to do. We have P implies Q, which implies P implies R. So then again, we want to get rid of the implication symbol. So not P implies Q or P implies R, and then we're going to work on the symbols within the parentheses. So not not P or Q, or not P or R. So we just worked on the inners of each. And now we're going to distribute this one inside here. So you basically get not, or I'm sorry, you don't get not. You get P and not Q, or not P or R. Pretty soon you'll realize little tips and tricks that you can do with this stuff. Right here I see an OR and an OR. So I can treat this as one variable, this is another, this is another, because P or Q is equal to Q or P. Well, same thing as P or Q or R, and you can rewrite these in any way you want, such as R or Q or P. So pretty much that's exactly what I'm going to do. I'm going to rewrite this, and I'm going to do P and not Q as one segment, or not P or R. So now, as you can see, I've moved this or not P within here. Same principle, let's go ahead and swap these two around, and we can go ahead and distribute it. Pretty much what we get is not P or P and not Q, and then we basically finish this whole thing off with or R. Next step is to distribute this not P or within here. So once we do that, we get not P or P and not P or not Q or R. So we've got to this distribution. Let's go put those parentheses around there. So the next thing is not P or P. So if P is true and not P is false, true or false, well then that becomes true. If not P is true, and then P is false, so true or false, again, that becomes true. So this turns out to true and not P or not Q or R. So true and anything else is just that expression. So true and true would be true, true and false would be false. So basically the truth factor is dictated by this little expression right here. So we can just get rid of this. It doesn't matter anymore at this point. So we get not P or not Q or R. So now we've got to the point where we can't do anything else. So let's go ahead and bring the other side down. So we have P and Q and not R, or the remainder of this expression. Well, here we go again. We have a left side, we have an OR, then we have a bunch of other ORs, right? So I think what I'm gonna do is I'm gonna work on this R first, move it over here, and let's see what happens. So let's go ahead and do P and Q and not R, and I'll work step by step just so you guys can see what's happening. Or R, or not P or not Q. So then we have P and Q and not R, or R, or not P or not Q. So now we want to move this or R in the beginning. Well, that's exactly what I'm going to do. R or P and Q and not R. So there we go, we finished that one off, or the remainder of this one, not P or not Q. At this point, well, what are we going to do? We'll go ahead and distribute this inside here. So we get R or P and R or Q and not R, or not P or not Q. So it almost seems like what we're doing is counterproductive, like it's actually getting bigger than smaller, and sometimes that does happen. I haven't worked this problem out, so I'm actually kind of excited to see where it goes. Who knows, maybe it isn't even a tautology. So we have R or P and R or Q, and R or not R. So everything is closed off. Or we're going to do it like this, not P or not Q. So at this point in time, we have R or not R. Well, that's true. And R or Q. And R or P. Or not P or not Q. Well, now something interesting happens right here. We're gonna do a reverse. Well, actually, let's just go ahead and keep it. Well, we might as well just go ahead and do a reverse. Let's see what happens. So R or P and R or Q is the same thing as R or P and Q, right? R or P and R or Q. And we can rewrite this as R or P and Q. And we can get rid of this true symbol, just because true and anything else is just that. Or not P or not Q. So here's another statement, and then we have these two segments right here. So let's go ahead and move one of them in here. So once again, because one side or this side or that side, technically we can even split this up a little bit more. There's one or, then another or, then another, then another. So let's go ahead and see if we can do it that way. Let's go ahead and first move this in here. So R or P and Q, or not P, or not Q. Well, then let's change this up a little bit as well. R or not P, or P and Q, or not Q. Okay, I think I'm starting to see a pattern right here already. I think this is gonna cancel out. So we get R or not P or P, and not P or Q. Okay, or not Q. So the next segment is we're going to get rid of this. So R or true and not P or Q, or not Q. True and anything else is just that something else. So now we have R or not P or Q, or not Q. Well, look at this. We've got to the point where everything is an or symbol. So now we don't have to group these two together. We can just group these. And I think it should go pretty simple from now on. R or not P, or Q or not Q. So where are we at right now? Q or not Q, that's true, or not P, or R. Well, guess what? True or not P? Well, that's true, or R, which is true. So there we go. After this whole long, massive, convoluted thing that we had to do, we finally reached a conclusion that the assertion, that the proposition, which basically is this right here, is a tautology, is, as a matter of fact, true. So pretty cool, and like I said, you guys, I hope you're excited about this. I'm really excited, and we'll see how it goes from here.